Hello guys, hello guys. Hello, my one viewer. 10 more minutes, then we start as we wait for others if they will join, that is. Um,
Why must I be tortured again by all this?
Okay, I think I'll just start. I'm not sure if there are viewers, but maybe they'll join when we continue. So today we are shading an image classifier. We are trying to predict if an image has landslide or not. Yeah, so that is what you are going to try today. In essence, you are trying to solve this Zindi challenge. We are trying to solve this Zindi challenge. The moment I'm at position 22, but yeah, and I'm only using gradient boosting decision trees, but now I want to shift to like an image classifier and see the performance. Yeah, so that's our goal today, man. Yeah, and the framework we're going to use is called fastai. Yeah, this framework, we are going to use this framework. This is the first documentation. If you want to learn about image classification or computer vision, you should come here, check their courses, learn about them. Yeah, this is the easiest, and not only computer vision, but neural networks in general. Yeah, you can come here, choose a course, yeah, and learn. It's pretty easy. So that is what you're going to do today, and yeah. I don't know if others are joining, but we'll see. We'll see. We'll see. Yeah. So let's start. So we're going to import some libraries. Pandas, obviously, for data manipulation. NumPy for mathematical operations. OS for pad stuff. random for seed, seaborn. Yeah, okay, we're not going to use seaborn or matplotlib. We are going to use the first AI is data block to visualize the image. We need augmentations. Augmentations is a library. This is for image augmentation. So you can visit the documentation. Yeah, fast and flexible library for image augmentation. For image classification, segmentation, and in all computer vision like tasks. I hope you can hear me talking despite the like background music. I hope so. Or I can reduce the volume. Okay, I hope it's more clearer right now. So also we're going to import team. Team on the other hand is, yeah, a deep learning library collection of state-of-the-art computer vision models, layers, utilities, optimizers, schedulers, data loaders, augmentations, and also training and validating scripts with ability to reproduce ImageNet training results. In essence, we use Team to retrieve the state-of-the-art pre-trained models which you are going to use. Yeah, and also we need to like import AI stuff. Import like everything. We are going to import. Okay, we're also going to import the validation strategy we're going to use, and we'll use, since this is a classification task, we'll use a stratified k-fold. We're also going to import metrics from fastai. The metrics import f1 score. I bet. Yeah. So if you come here, you'll see like the competition metric is f1 score. So yeah, this is what you're going to use. Other than that, ignore warning stuff. Ignore. Do we need? Oh yeah, we need GC. GC is garbage collector. We'll use it to. Oh, and we also need touch. Yeah. And now I'm using Google Colab, so you can either use either these GPUs. I'm on Colab Pro, so like I'll use the GPU which is available to everyone, which is T4. Yeah. And then we connect. If you come here, check the resources. So I have like very little compute left, like 3 units. Yeah, no problem. But you see, you get access to like a GPU with like 15 GB VRAM. Yeah, and you can also like get access to like high RAM, etc. But in this session, you only need like the GPU, so that's what we are going to use. Yeah. So I think we have imported all the necessary libraries or dependencies, and yeah, we start. So the first thing I like to do is setting seed for reproducibility. F1, yeah. So like we need to like check the correct name of yeah. So you come here to check F1, 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 F1. F1, yeah, metrics. So you have accuracy. Yeah, here we have F1 score. So it's not like the one provided by Escalan. So import F1 score. Hopefully this works. Yeah, it works. So we set seed for reducibility. I mean, reproducibility means like every time you run your notebook, you get the same result. Um, yeah, I'm going to use AI. Yeah, yeah. I think that's it. Yeah, so that's it. And then you set the seed. Um, so now we have set the seed. Now we have now reproducibility. The next thing you're going to do is load the data we are going to use. So in essence, like they're provided here data, 1.9 GB, 1.4 GB, the CSVs to link the images. It's not like images, you have to create the images yourself, since what has been provided is NumPy files. Yeah. So you have to create the images yourself. I'm not going to do that in this stream. I have already created the images. It's a time-intensive process. Yeah. So first you're going to link our Google Drive. Yeah. Once you link our Google Drive, you just need to follow the steps. You'll be prompted. And then now we can set the path of our data. And yeah. So if you come here, you'll see your drive linked. So we find it. We find the directory. Yeah, this is my directory. I have my images here, train and test. I have my CSVs here as well. So like the parent path, this is the parent path. And then every other file can be built from this now. So if you need the train sets, it's pd.read.csv. If you need the test sets, yeah, I think these are the most important. And now we need to like set the image path we are going to use. So this is constants. So image path I have. So like I've said, you have to create these images yourself. So we're going to use one of these combinations. So yeah. So like this is not the parent path. Oh yeah, we can actually set different paths for each file. Like since we have divided the paths to either train or test. Yeah, and we are done with this section. We can close it now. We have all we need. Something I like to do is add the closing slashes. We'll see why in a minute. Um, yeah. So like computer vision is actually the one of the easiest. One of the easiest. One of the easiest competition you can do on Zindi because maybe easiest is relative. There's no like too much feature engineering, and you can get a decent score either way. But some require like some require like some advanced augmentation feature engineering. Uh, so computer vision is actually easy if you know what you're doing. If you know what you're doing, that is. Yeah. So as you can see, like we have like the IDs and the labels. And okay, we can check the distribution of the label. So label the value counts. As you'll see, like this is a real imbalanced data set. So, but in essence, you actually don't need to like handle like the imbalance nowadays. Not even nowadays, because like for example, in tabular competitions, most people, not most people actually, like people use some like oversamplers, for example, modes or the traditional oversamplers, which add synthetic data sets or like they repeat the same rows in like in the imbalance class, and this is not like what you'll get in the real world scenario, or and it doesn't generalize well. Okay, sometimes it generalizes, but what people do as a backup plan is they use a good cross validation technique. So, for example, so there are two okay, not too many, but when people learn about machine learning, they learn about trend test splits most of the time. So, trend test split is good, yeah. You can do stratification there, and you can create like at 80-20% distribution, but um, for generalization you actually have to use a more robust cross validation technique. So we have so we have like a cross validation technique called certified k-fold or k-fold for regression tasks. Yeah. So this is what we use most of the time in competitions. It's generalizable because it's like let me show you the images. Yeah, this is a good image. So what this is your typical like just this top image. We have like 5 folds. So the first fold is like your typical 20%, 80% training and test set. But now you create like 5 of them, and in each 5 of them you continue shifting where you are setting the 20% validation. In essence, after all the 5 folds, you will have trained and validated on all the folds, and then you average the results, and this like generalizes very well. So that is what you're going to use. Um, yeah. Sorry. I'll have to like add it. Sorry, it's my first time streaming on Twitch, so I'll have to like add a new. Wait, you cannot see the Google? Oh no, not the Google. Sorry. I think you can see like the images I'm talking about. Uh, yeah. So like you have to like uh. Okay, most people use stratified k-fold, and stratified is for classification, then the normal k-fold is for regression. Because in stratified, you have to maintain the. Oh, okay. Let me check. Can you see like the image, Wayne? Can you see like the k-fold image? It's dark? Why? Why? Let me see. Hmm. I really don't know why, because in my like stream manager I can see like the k-fold image being displayed. So I really don't. I'm not sure what's the issue. Okay. Let me know if you can if we are back to the notebook. Let me know if you are back to the notebook. Can you see the notebook right now, like the Google Colab? Okay, let me fix it then. So I asked my cousin, and he can see my notebook. I'm not really sure why you cannot. Uh, maybe like rejoin. Uh, maybe like rejoin. Yeah, maybe like rejoin. So we were talking about the k-fold. That is what we are going to use due to the imbalance. Um, so the next thing we are going to do now is set up our config. So a config is something I like to use to like set up every parameter or paths or general thing that I would like to use in my pipeline. Uh, so that I don't like, so that I have like one single point of changing these things. So you can use a data class, you can use a normal like class. So for example, number of splits, we are going to use like 5. The seed we are going to use, what seed did you use here? So 42. image. Oh, we have set the image path or image size. So like, if you look at these images, let's see. Um, yeah. So what we have to do here is like set up our image path so that you can access the image. So the image path is simple, like you just do, yeah. Oh, we also need to like add the extension, which is PNG. It varies. My images I set them as like with the PNG extension, but you have to check yours if it's PNG or JPG. Um, yeah. So image ID. Okay. Let's see. It's ID, not image ID. Uh, yeah. So we set our ID. Nice. So we have added a new column, which is not there, called image path. Now this image path, you can use it to like access our images. So like for this image size, you'll realize that most of our images are like they have it's a square of like 64 by 64 pixels as the width and height. So we can check for one. The size. Yeah, you can see like it's 64 by 64. So we can either resize it to like because most of the pre-trained models they use like the 224 by 224 as the width and height, and yeah, so you can either resize it or you can use models that can be trained by 64 by 64. So you're going to use like the 64, the default one. Then you use like something like efficient nets. By efficient, yeah, you can use efficient nets. Or any other model that supports random like width and height. Yeah, but if you need to use like something like vision transformers, you have to like check which image size the vision transformer was trained on, and then train using that image size. And where do you check like these things? So like when you go to team, not even team, Hugging Face. Yeah, when you go to Hugging Face and you look for the computer vision models. So for example, I'll check convex. Yeah, so I'll check this convex tiny. So you can see it has an extension with 224. This means it was trained using images of size 224 by 224, like squares of size 224 and 224. And it's crucial for you to train the models with the same pixels or the same resolution in which the pre-trained model was trained with. But it's not like, okay, some like they enforce it, but for others like efficient nets, they don't. You can use any image. I mean any image size. Yeah. So we are going to use image size of 64. Model name. So model name, or let's use 224, and then we use the convex tiny. So if you want to like check which models are supported by team, you do team.list models. Yeah, when you list, it will list for you all the models. But if you want only convex models, you just do that, and then it will list for you all the convex models that you're going to use. So this is what you're interested in, the tiny one. Yeah. So you can play with this, you can play with this, you can play with this, and find the appropriate model name for yourself. Then batch size. I feel like we can even use 64 batch size because, okay, 32. But this you can play with as well. Like you can, if the GPU utilization is not 100%, yeah, you can change that. Epochs, we can use like 12. TTA, okay, TTA is an advanced topic. We'll get there. We'll get there. It's called test time augmentation. Now this is an advanced topic. I don't even think we'll talk about it today. Number of classes. We have seen like it's only two classes. So it's a binary classification task. If there were more than two, it would have been a multi-classification task or project. Yeah. So we have our config. So we can initialize it. Nice. Yeah. And then, so now when you want to access any of these initialized variables, just like call it, and you see like you get the end splits, for example. Yeah. So this like it makes your work easier. Since you only have one single point of like tuning your configurations. Exactly, that's why it's called config. Tuning your configurations, not parameters or hyperparameters, because hyperparameters are for training. Yes. After that, now this is, we don't need this anymore. We have already confirmed the image size, and all of them are 64 by 64. We go to cross validation. Yeah, now we have talked about k-fold. I mean stratified k-fold. That's what we're going to use. So we initialize it. We had already like imported after. Yeah. So we have the end splits, which is 5. Shuffle, which is true. Shuffle means like randomize the order. Random states is the reproducibility. So every time you create these folds, you get the same fold distribution. Yeah. Actually, the AI knows. So we set like we initialize a column fold with a random fold number like -1, and then we overwrite it with the appropriate. So if you check this column after creating the folds, you'll see we have 5 folds. Yeah, we have 5 folds, each with almost 1,430 images. So, like now, imagine we set 0 as our validation set, right? We will train with fold 1, 4, 2, and 3, and then validate on 0. The next round, we'll set 1 as the validation. Then we'll train on 0, 4, 2, and 3. The next other round, we'll set as 4 as the validation. Then we'll train with 0, 1, 2, and 3. The next one, we set 2 as the validation. Then we train with 0, 1, 4, and 3. The next time, we set 3 as the validation fold, and then we train on 0, 1, 4, and 2. Yeah? I hope that's clear now. So after setting our cross validation, the next thing we're going to do is define our augmentation. Our augmentations in computer vision, they help in preventing overfitting or reducing overfitting. Okay, yeah, reducing overfitting. So let's check which AIs do you guys use? Which AIs do you guys use, man? I don't want to use ChatGPT because it has very crazy charts, man. Yeah, so let's ask the AIs, man. Everybody should use AI, bros. AI makes things easier. Bro, this doesn't even need thinking, man. Like, why is it thinking? It doesn't need thinking. Like, yeah, building robust and generalizable models is the practice of artificially expanding the size and diversity of our training dataset by creating modified versions of the existing images. So how we do this is by uh, is by how you do this is by resizing, rotating, uh, yeah, transposing, enhancing the brightness, the contrast, things like that. Yeah, we artificially like increase the size and diversity of a training dataset to improve the generalizability of the models. So you can go read more about augmentation, and my favorite augmentation library is augmentation. Um, yeah, just a minute. Just a minute. Yeah. Cool. So we're going to use, but fastai. I mean, fastai hasn't built like augmentations. So like it has fastai augmentations. So you don't need to use augmentations to be honest. You can use like yeah, you can use like the fastai inbuilt augmentations. So you have uh yeah, this is a good illustration. Yeah. So you have crop pad, you have random crop. These are all are augmentation. You see, like these are different, like diverse images from the original one. Resize, and there are different ways of like resizing. Resize, we have squish, pad, crop, random resized crop. Yeah. Um. Yeah. So you can use like the inbuilt fast AI augmentations. So yeah, you can just like research, go to this documentation, see what like different augmentations do. Yeah, and learn from it, and learn from it, and learn from it, man. Should we use augmentation or fast AIs? What do I think? What do I think? Let's use augmentations. Let's use album. But like first, the fast AI one is very easy to start. So we create a class. Uh, Actually, like it knows. The AI knows. Yeah. Finish for me, AI. Finish for me. Come on. Yeah. Uh, yeah. Yeah. And it's simple as return augmented image. Yeah. So the AI knows actually. Then now for okay, these augmentations in essence, we do them mostly in the train set. So we have to create two different functions. One for creating train augmentations, and the other one is for validation augmentation. Because in the real world, you predict only on one image. not like diverse sets of image. So we try to mimic that. And for the validation set, we only like augment using maybe resize. Yeah, to resize the image into the one which you find or which you fine tuned your pre-trained model on. Yeah. So uh so we then yeah. So there are different types of augmentation, like as we have seen, like in the past AI's documentation, there are different types of augmentations you're going to use, like in general. So for me, in this stream, I'm going only to use like horizontal flip, vertical flip. So you know what flipping is, yeah? I feel like that's enough. Yeah, I feel like that's enough. Um, yeah, and then for 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 for, for validation, we only resize. Nice. Yeah. Also here we need to resize, by the way. Yeah. Thank you, AI. And then we create something called items transformation, which you're going to use in the data blocker. Data block of first AI. For first AI, yeah. Yeah. The AI knows, man. It's so easy to build nowadays. And then that's for a single item. Then we have batch transformations as well. AI, please do it for me. Hmm. Do I need that? Do I really need that? Aug transforms? Nah, we need only to normalize from stats. Then we have ImageNet stats. Cool. So we have now the item transformations and the batch transformations. Uh, but in essence, honestly, you don't even need to do this. You can just use like FastAI's inbuilt inbuilt transformations, to be honest. So like when you come here, fast AI image classification example, like that's just overkill. You can just yeah, you can just like use the inbuilt fast AIs. Yeah, for example, you see for batch transformations, they're just using aug transforms, and us we are doing like a lot of things to just get that. So we have to define all these classes. Then for us we are normalizing. Yeah. Um, what is it? Yeah. So we create a data block, the image block and the category block. This is for the image, this is for the label. Get image files, get y. Oh yeah. Item transformations, they only resized. And then batch transformation, they used aug transforms from FastAI. And then they only did like a resize and a main scale. Yeah, that's pretty simple. How to create a batch. I mean the transformations. And you can add a bunch of like transformations, man. The one shown on the documentation. But for us, we're using augmentation. That's why you're seeing a lot of code. You don't need all this code, to be honest. So depends on your preference. Now we define our data block. Get data block. We are doing this so that we use it in our training loop. Or in essence, if you had only a train test split, you don't need functions. Yeah. Batch size. Uh, Return. So we set a data block. I don't know how to explain data blocks. Like, um, let's look at the documentation. Data block. Yeah, so data block is a generic container to quickly build datasets and data loaders. You need to give the library four things: the types of your input and labels, and at least two functions: get items and splitter. Get items is to like get items from your Google Drive, like get the images on your Google Drive, and splitter is now the cross validation technique you're going to use. You will also need to include get X and get Y. Get X is the image part where the image is. Get Y is the label. Yeah, and they are more like generic list of getters. So in our case, we are passing in an image block and a category block. Then we get X and get Y. Get X gets the image part where the image is stored. Get Y gets the label, what the label is. And then we have to specify our splitter. Our splitter is how we are doing the cross validation. Yeah, and since we are using a stratified keyfold, we do that. But in essence, there are many splitters. We have random split. We have random split does the 80-20. You can specify your own test size. Yeah, and also we pass in the item transformations and batch transformations, and then we initialize it. We call the data loaders methods. Yeah, and then using our train. Yeah. Now let's see if our our data block works. This is the fun part. The start of the fun part. Now we're now seeing like your work. So get data block. The get data block function you have created. Then show batch is method, and then we can specify the figure size, which is 12 by 12. Let's see if it works. Hopefully it works. But it seems it's working because it's taking a while to load the images. Tensor object has no attribute show. What? Tensor attribute doesn't have the um, get X, get Y, splitter, item TFMs. Wait, let's try the transformations from this. Yeah. Uh, batch transformations. Let's see if it's the transformation which is causing the issue. If it's not, hey, finally we have it, man. The fun stuff, the fun stuff. So we have our labels plotted alongside the images. So for example, this doesn't have a landslide, 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 this has a landslide, and looks like it in a way. I'm not really sure. This doesn't have a, this doesn't have it, this doesn't have it, this doesn't have it. And this like it's actually random. The next run you do it, you'll get different. Oh, so the issue, the error was caused by this transformation. I feel like we have made an error somewhere. Um, yeah, I feel like we have made an error. Uh, okay, at least now this works. So yeah, we are going to fix it later. Actually, we can comment this out. Cool. Now we have our data block and it's working. Now, hey, now we get to the most fun parts. The most fun parts, which is modeling. So, modeling. First, we have to initialize our metrics which we are going to use. So we are going to use F1 score, but you can actually freestyle here. You can use F1 score, you can use accuracy, accuracy. Yeah, you can use a lot of metrics which you think like they are fun to you. So accuracy. Uh, yeah, I hope that works. Accuracy is not defined. Are you kidding me? I just defined it up here right now. Oh, accuracy. Accuracy. Now you have the metrics. Now, now we create the folds. Let me take a quick break. I'll be back. Oh, cool. I'm back. I'm back. I'm back. Um, Now we go to the fun parts. Now, let me tell you something funny, yeah? You see, like, for example, a binary classification task. It's the, okay. It's one of the easiest competitions you'll ever do, bro. Like, it's one of the easiest, as long as you have the data. Bro, let me tell you. All you need to change is this part, where you load your data. Because you'll have different data every time, right? Then, and to check like if the images have PNGs, like just this part is the most crucial, and this part right here, because you'll just be like experimenting with different models, the image size as well, based on the pre-trained image size, the number of epochs, the batch size. This is for GPU utilization. TTA, we'll talk about TTA later. This is for inference. Yeah, and for binary classification, you always have two classes. So all you need to worry about is the data, how you're loading the data. And yeah, you don't need to worry about cross validation because it will always be certified K-fold for like binary classification. And also now the data block. You don't even need to change this. This is a, you just need to like, okay, maybe change the, if the image path, you have named the image path wrongly, or the label, like not wrongly, like you have a different column name. Just change here, even the fold name. But in essence, it will remain like this. Like it will always remain like this, competition after competition after competition. Now, where people like do like some stuff is this right here. That's only where you use your brain, because you have to find like augmentation that works. You have to create, if you're a pro, you have to create like custom augmentations for different competitions to handle different things, huh? Now these are the two things you'll change, but for like for a baseline, you don't even need to like worry yourself about other things. Just use this as a baseline and you're cool to go. Yeah, and now the metrics of obviously. So like if the evaluation metric is like F1 or accuracy, you do the necessary. That is only that is, imagine that is the only thing you have to do. Like that is the only thing you have to do. And then now when you go to multi-classification, all that needs to change is this. So you just need to add here multi-category block, and then you come here at to the docs metrics, um, metrics, and then find all metrics that have multi in them. Like, yeah, so you have multi, 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 F1 score multi, then use those metrics, because if you use the normal ones, there you'll get errors. Yeah, so you have metrics now, and yeah, yeah. So what we are going to do is, now since you have the metrics, now we are going to write the cross validation loop. So first you need to initialize, like OOF means out of fold predictions. These are predictions of the folds that you're validating, on. Yeah, actually it knows, and we have two classes, so yeah, you initialize it like that. Do I need this? No, just need a list to store the fold test spreads. Now this is where cross validation comes in. Remember we have 5 folds, yeah? So we say for fold in range, the number of folds we created, which is n splits. This means it will iterate. So let's print the fold. Actually, let's print something which is more, what is it called? More descriptive, yeah? We are validating on fold, yeah? So this will, exactly. So the first iteration, we are validating on fold 0 and training and training on fold, yeah. Actually no, yeah. Let's see. No, this is not correct. We need to like, and training on fold, yeah. Thank you, AI. Fucking hell. Sorry for cussing. Exactly. So we are validating on fold 0 and training on fold 1, 2, 3, and 4. We have validation on fold 1 and training on fold 0, 2, 3, 4. We are validating on fold 2 and training on fold 0, 1, 3, and 4. So in every validation fold, we remove it in the training folds and then use all the other folds for training. I hope now that is more descriptive, yeah? We'll leave that there. So first thing, we create our data loader. So get data block, use our train, use the fold. Remember the arguments here: fold, batch size, Yeah, batch size. CFG batch size, yeah. Nice. We don't need to show the batch here, so we are not going. We have already seen one of them. Then our learner. If you come here to fastai docs, learner. What's a learner? What's a learner? Group together a model, some DLS, and a loss function. DLS is our data loader. Data loader samples. I feel like that's the right terminology. I'm not sure. And the loss function. Yeah. For binary classification, we use cross entropy loss. So yeah, we are going to search cross entropy loss. Actually, no, we are going to search for loss function so that we see all the loss functions that are provided. So we have cross entropy loss flat. It flattens inputs and target. This is what you're going to use. The cross entropy loss flat. There are more focal loss flat. Same as cross entropy, but with focal parameter. Focal loss is introduced. Now that you have focal loss, the normal one. BCE with logits loss flat. Binary cross entropy. We can also use this, I bet. Yeah. We can go through this documentation. And now we create our learner. Now this is the fun part, man. So we use vision learner because this is a vision task. This is a computer vision task. And first it has different learners. Like it has a text learner, it has a tabular learner, etc. But since you're doing computer vision, this is a vision learner. And then we add our data loader. We add our model name. What's our model name? Actually, I feel like okay. CFG the model name. Remember our model name up here. Yeah, we are using convnext tiny, convnext v2 tiny. Yeah, you can change this actually. Like yeah. You can choose whatever. Oh yeah, so Hugging Face has a like. I feel like it has a vision leaderboard. I've never seen something like that. Yeah. I don't think it's this though. I don't think it's this. No, it's not this. Computer vision model leaderboard. This for object detection. Is it this one? But like it has like I've ever seen it, and Comnex something was leading at that time. Not object detection. Okay, I can't remember. But yeah, you can go research. Cool. We define our model name. Remember the documentation, yeah? A learner groups three things: the model, the loss function, and the DLS. Yeah. So group together a model, DLS, and a loss function. So you have to make sure all those three things are there. So our loss function, which you're going to use, is we can use BCE, the logits loss flat, or we can use cross entropy loss flat as well. And the metrics, and the metrics, since you need to like see how well your model is performing. And then you just call random fine-tune, but wait, there's a trick we use to find the learning rates, the most optimal learning rate. So fastai has something that is called a method that is called LR find. So it's a learning rate finder. Yeah, so it returns two values, the valley and the slide. So so we call, now we have initialized the learner, so we call learner.lrfind suggest function. So we specify the valley and the slide. So I'm going to, okay, let's see. First AI valley and slide. Yeah, no, lr find, lr find, lr find, lr find. Where is the lr finder? uh nice. Exactly. So you can see like there are four things you can find using the learning rate finder. So the minimum, the steep, the valley, and the slide. So this picks up like the initial learning rate. So the graph above can be divided into three zones. Shallow zone, where changing learning rate has minimal effect on loss. Linear zone, where we observe a quick drop in the loss function. And divergent zone, where learning rate is too high, resulting in loss to bounce and ultimately diverge from the local minimum. Ideally, we want to work in the linear zone, where there is a steepest drop in loss function. Minimum is where gradient of loss function is not changing, and we do not want to operate here because that will result in not being able to update the weights. A rule of thumb will be to pick a spot that is an order of magnitude less than the minimum. So in our case, using LR, we have the option of using steep, valley, or slide. Any of those will work just fine. I've decided to use valley, and in my case, I only find the valley and the slide. Yeah, so you can test with both of them and see which works well. But I love to use the valley as well, just as in the article. So we call our fine tune method. Now this is the fun part. This is where now we train our model, we fine tune our model, our pre-trained model. So remember the epochs we defined in the configurations, and now we use the optimal value that was found. Yeah, in essence, when you do this, we are training now. So let's. Are you guys ready? Are my two viewers ready to to see a model train? If you're ready. Oh, my four viewers right now. My four viewers. We are at the fun part, man. We are at the fun part, yeah? Are you guys, if you're ready to see the model train, type in the chats. Type in the chats, man. Type in the chats. Type in the chats if you're ready to see a model train, like our computer vision model, our neural network train. Type in the chats, guys. Then we are going to initialize our first training run. It's fun, bro. It's fun. But anyways, since no one is typing, I'll just initialize it. Cool. Now this is asking me for my Hugging Face token. We load our model. The first thing we need to check is if the GPU is being utilized fully. Yeah, we need to check if the GPU is being utilized fully. At the moment, the model has not even been loaded yet. So let's see. Oh, it has been loaded. Yeah, it has been loaded. 115 million parameters. Target size must be the same as input size. Huh? Okay. I think this is the issue with the loss function. Cross entropy loss function. I hope so. I hope so. Cool. We are F training, bro. We are training, man. We are training, but the GPU is not being utilized fully. So you might need to like increase the batch size. Yeah. By increasing the we might need to increase the batch size. So yeah. At the moment it's not training yet, it's finding the optimal learning rate. Yeah, so we be patient until it gets the optimal learning rate. I'm not really sure why it's too slow. It should be faster than this since you're using the GPU. But it should be faster than this. Yeah. So this is the loss here. So like it's finding the optimal value and slide with the lowest loss because at some point this loss will explode and then it will get worse and worse and worse and worse. So and then it will stop the optimization, like not the optimization but the learning rate finding. Yeah, and then it will return for us the two values, the value and the slide. Yeah, bro, this is what the first time I trained my first computer vision model, I was so excited to see like just these values update, man. Like I was, I was super excited, bro. Like when you train your first models, be it like computer vision, no, like be it an image classifier, an object detector, image segmentation, yeah, um, vision language, vision language model fine tuning. It's always exciting. Yeah. So we're going to chill a little bit, a little bit, a little bit. I don't know why it's super slow. I feel like the batch size, if you reduce it to 8, it will be faster though, but the GPU utilization will be super, super, super slow. I mean, not super slow, but pretty trash. So yeah, for the stream, maybe for the stream, let's experiment with different batch size. Instead of 32, we use 8 or 16. I feel like 16 is pretty good. Um, yeah, let's see if it will be faster, hopefully. It's still slow though. It's still slow, but let's be patient, let's be patient. As we continue to wait, any questions on the chat? Yeah, I need to master the double streaming thing. I feel like most people are not like well conversant with Twitch, so maybe I'll start like doing dual streams, YouTube and Twitch. Hopefully, yeah. Now this is the waiting game. This is the waiting game. Until you see those metrics is when you'll get satisfied at least. But yeah. As we continue to wait, let's recap what we have learned today, yeah? Oh, so the GPU RAM utilization is like half, 50%. We need to like double this. It's because we have reduced the batch size. So yeah. So let's recap. Let's recap. Yeah. So the first thing we did is loading the necessary dependencies. loading the necessary dependencies, and then the next thing we set the seed for reproducibility. Then we load the data, and as I've told you, the only thing that changes in most competition, especially if you find like a binary classification, because this is a binary classification challenge, it has only 2 labels. Multi-classification has more than 2 labels. Where the data is and the data that you're being provided is what changes, right? So this is where like you'll do most of the work. Then all these, like imagine you can use, like you can take these templates and substitute all your binary classification project. Yeah. Also here, these are the things that changes. Convex tiny, for example, changes to the model you want to use. The image size changes, and as I told you, like different models have different image sizes. So the same convex will have others trained for like with like 384. Let's see. If we, yeah, see, like for example, convex large was trained with 384 by 384 height width dimensions. Yeah, so that is what changes. Batch size changes depending on the GPU you have. So to like have a pretty good GPU utilization. The number of epochs changes. Now this is what you'll experiment more with. Also something else, if you're not using the LR finder, you'll have like a default learning rate of like 2, something like that, or 2e minus 4. So this will be a starting learning rate. But since you're using a learning rate finder, we don't have to use this. Yep. So other than that, nothing else changes. Oh, the number of splits. If you want like 10 folds, 15 folds, you just change that. After that, you create your loop, like your folds, yeah? Then this, I told you, like if you want custom augmentations, and if you want to use augmentation, you can use this class, but it has an error, as we saw. So I'll try to fix it before I post this like notebook on GitHub. And then you create a data block, and a data block essentially, as you have seen, takes in like the blocks. Oh no, this this is supposed to be category block, yeah? It's a multi-category block. It's supposed to be category block. Wait, are we trading? Oh, cool. Yeah, it has already. Yeah, it has already finished the LR finding. Yeah. Oh, so the data block gets. I mean, the get X, get Y, the splitter, the item transformations, and the batch transformation. Get X is the image path where the image is stored. So you have to have like the full image path, and the get Y is the label. So in essence, if you have like followed all these steps, nothing changes here. Nothing at all, except the item transformation and batch transformations. Remember, like we looked at the transformation we can use, yeah? Like there are very many transformations you can use. Random crop, transpose, enhance the brightness, contrast, a lot of augmentation. So you like go crazy here. Yeah. So at the moment you're only using resize, yeah? Then we show the batch. So this will print the image. If you have done everything correctly, you'll get the image and the label printed on top of it. So you can see this doesn't have a landslide, 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 this has a landslide, this has a landslide. So in essence, you're training an image classifier to check if the image provided has a landslide or not. So what we are trying to solve is this problem right here. So this competition, which ends in 12 days, yeah, and the metrics is, yeah, these are the metrics. So it has failed because we are using cannot identify image file. Oh really? So some images are missing. Some images are missing. Some images are missing. How are we going to fix that? We're going to fix that using, we're going to check os.list directory train image path, calculate the length. We need to compare it to the train shape. They're actually equal, bro. Like what? 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 So I don't understand why it's saying like some images are missing. Yes, these are the problems you'll face. Debugging. Debugging, bro. Debugging. Data structures, bro. Data structures. Data structures, bro. So use a set and then we find the difference. Minus. We find the difference to see if which image parts are missing. Yeah. I mean it's empty, bro. Like what? It's empty. I'm really sure. Like I'm not sure what's happening right here. Like no image is missing. Like every image is present. Like, I mean, let's try to restart. Hopefully it works this time, man. Like every image is present. Yeah, that's. I feel like everyone here understands the set. Yeah. The set returns distinct values. So we are trying to check if the image file values we have created right here all are present in the directory. So it returns an empty set, like the difference, use minus for the difference, yeah? It returns an empty set, meaning like all image paths are present. So like I don't know where that error is coming from. I'm not sure where that error is coming from, bro. I'm not sure. I'm not sure, bro. Let's restart and run. Oh. Yeah. So yeah, where were we in the explanations? Yeah. So here we create a data block. A data loader. Then we show like samples of those images. Then we define the metrics we're going to use. The metrics is defined by the evaluation. So Zindi competitions always have metrics for you to optimize. Yeah. So for this is F1 score, but you can go crazy here. Like add all manner of metrics you want to like check while the training is running, and then here. So in essence, what you're trying to do is stratify k-fold. So at the first iteration, since like the number of splits are 5, yeah, that means it's 5 folds. So we are the first iteration we are validating on fold 0, meaning the fold 0, damn, my Kikuyu in me. The fold 0 is like we get rid of fold 0 in the training folds and use it as a validation set, and it becomes the 2080 like 10 test splits that people are used to. Then the next iteration, we check, we set like fold 1 as the validation, and then we use fold 0, 2, 3, 4. In essence, the validation fold is not used in training. So for the 5 iterations, you'll have validated your model on all the all the data samples in your training set, and trained on all of them, and then we find an average, which is called ensembling in simple terms. We ensemble the 5 models using average or mean, yeah, and then we find a generalizable result. So after we create the folds, after we iterate, we create the data loader, we create a learner. So in essence, this is a computer vision task, so we use a vision learner. We specify the data loader, the model name, the loss function, and the metrics. The loss function changes competition. Task by task. For example, regression, we don't use cost entropy loss plots, so this changes in different computer vision tasks, and the metrics as well. So for what is it called? For regression, we don't use like accuracy and F1 score. We use root mean squared error or mean absolute error. Nice. It's pretty fast right now, yeah. Yes. And also fastai it gives you like an estimated time to finish, yeah? So right now we are left with 52 seconds. 52 seconds to see our metrics, bros. Our metrics, bros, yeah? Fucking. Oh, sorry for cussing. I don't know why. And I'm pretty sure this is present. Like if you try to like plot it, it's there. Like what? It's there, man. Or is it? I'm not sure why. Oh, so it's not there. What? Are you kidding me? But we found like an empty set. What am I doing here? Yeah. Debugging issues, bro. PNG? Are you kidding me, bro? Come on. Come on. Like, come, like literally. Like this should be. I'm not sure. Man. I'm not sure. I really don't know. We are getting we're getting an empty set, literally. But when we try to like check for it, cannot identify image file. Unidentified. Okay. There are many ways to kill a rat. Train. In essence, we are dropping that ID from our training set because it's returning, like it's saying it's not there. So right now we should get like one less sample. I hope there are not. Yeah, there was 747, so you have dropped that one. I hope they are not like it's that only, like because you'll have to like do a lot of these shenanigans. Yeah. Anyways, we will get there. We have to see the metrics before I end the stream. I know like the time, it's already 10. I was like purposing to end it at 10, but I won't end it until we find like we see our baseline metrics at least. Let's hope it's like around 80. Yeah, because now from 80, because like the score to beat is 94. Yeah, we have to beat this. We have to beat this 94, bro. We have to. Like right now we are at position 22. We are at 0.88. So if you want to have like, if you want to win them the prizes, oh, they are prizes by the way. 500 CHF. 500 CHF is around 80,000. 80,000 Kenya shillings. CHF to, yeah, it's around 80,000. So bro, like it's free money, man. All you need to do is sign up, bro. All you need to do is sign up. Let's hope it works. Let's hope it works. Let's hope it works. Everybody, fingers crossed, man. In our next stream, which might be tomorrow, we're going to do inference. After we've trained the models, we're going to do inference and submit on the leaderboard and see what score we'll get. And then in the other stream, in the other subsequent streams, we'll try to like change the augmentations. We're going to change the model, but the problem is we cannot like stream the whole session since like the training takes time. The training takes a lot of time. So I'm going to like be changing, or I'm going to be doing experiments locally, and then in the stream I tell you what works, and then we like redo the not redo, we add the improvements while doing while in the stream. Like since this is a deep learning project, like deep learning projects really take a lot of time to train. So yeah. Hey, but like I see, like yeah, we have some like we have processed almost all of them now. Bro, bro. Like, come on. We can't catch a break, man. Exception occurred in recorder. This is what is it called? This is it's a metric issue. So I'm not really sure, but I think we used a category block, meaning that yeah, um, yeah. I feel like metrics. Let's get rid of. Let's see. I feel like it's a metric issue because error, I mean, it comes because of like wrong metric calculation. So it's either the F1 score, which is leading to that error, or the accuracy score. But let's see, man. Let's see, bros. Let's see. Hopefully it works right now. At least like the validation loss is reducing. You see? We are at 72 right now. We'll get to 60. Yeah. We'll get to 50 now. Yeah. This gives me hope. This gives me hope, bro. This gives me hope, bros. This gives me hope. This gives me hope. Yeah. I feel like okay, it's going to fail. I feel like it's the. I'm not sure. I'm not sure. Let's see. Let's see. Right. Let's see. Let's see. It's either the F1 score which is leading to that error or the accuracy. Yeah. But let's see. Let's see. Yeah. Um, that failed. Let's see with accuracy right now. Any fast AI pros on the stream to help me debug? uh, yeah, I'm pretty sure though it's a metric issue. It's a metric issue. So we go back to the documentations, man. Metrics. F1, 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 F1 scope. Error rates, accuracy, F1 score. Yeah, F1 score, axis labels, average binary. Labels none. Sample rate. It may be actually it may be like something as stupid as this, bro. Uh, F1 score. Something as stupid as this, bro. Like since it's only two, and then we pass it here. It might be something as stupid as that, bro. Like literally. But we are going to see, man. We are going to see. Told you, told you. It's a metric issue. Accuracy is working. Accuracy is working, bros. And we are, bro. But accuracy is different from like uh F1 score in imbalanced data sets. So like we might be happy here that the accuracy is good. We are at 0.8, like this is 84% accuracy, but since it's an imbalanced data set, the most appropriate metric to use is like F1 score. So we're going to interrupt this and then we repeat with the F1 score now correctly initialized, and let's see if the error still persists. We have to like evaluate our models using F1 score because that is the most trustworthy metric to use in imbalanced data set. And actually, you can even ask AI, bro. Like, bro, we have AIs, bro. We have AIs. Where is my AI? Why is F1 score? Why is F1 score preferred to accuracy in imbalanced dataset? Bro, this does not need thinking, bro. Come on. It should be automatic, like ChatGPT or something. But let's think, let's think. Yeah. In the realm of machine learning, especially when dealing with imbalanced datasets, the F1 score is often preferred over accuracy as a performance metric. These preferences This preference stems from the inherent limitations of accuracy in scenarios where the distribution of classes is skewed or imbalanced, which can lead to a misleading representation of a model's effectiveness. An imbalanced dataset is one where the classes are not represented equally. For instance, in fraud detection, the vast majority of transactions are legitimate. The same here, the vast rows don't have landslides, but the minority have landslides, while only a small fraction are fraudulent, yeah? Similarly, in medical diagnosis, the number of healthy patients often far outweighs those with a specific disease. For example, cancer. How many people in 10 have cancer, like might have cancer? Like 2 or 1, yeah? In such cases, a model can achieve a high accuracy score by simply predicting the majority class for all instances. For example, if 99% of transactions are not fraudulent, a model that always predicts not fraudulent will have an accuracy of 99%. That's why you don't use accuracy in imbalanced datasets. While this code seems impressive, the model is entirely useless. Yeah, it's entirely useless, as it fails to identify any fraudulent transactions, which are the most important. The same here. I told you. I told you, bros. Like, it might be as simple as this, bro. Like, imagine. The previous time we had just initialized uh, a stupid, very stupidly, but that was our bad, yeah. So we have to like initialize the metric with array, yeah. Um. So you see, we have like high accuracy but low F1 score. So if you use accuracy, like in an imbalanced data set, then you're lying to yourself. I hope that I hope you have learned a thing or two now. So this is the fun part. We are waiting for our models to improve, man. We have to get to we have to get to this guy, bro. Like we have to. And we have to do it live on stream, bro. Live on stream. Imagine if it gets even like at least okay 93% on stream. It will be so fucking cool, bro. Yeah, that's my goal. That's my goal. Hopefully we get to see like 90 scores in the stream. Yeah. Hopefully my 5 viewers now will will benefit, bro. Yeah. So right now you're watching a machine like a neural network being trained. If you've never seen a neural network being trained, then this is your first time seeing a neural network being trained or fine-tuned. And fine tuning, we are fine tuning this model, Convex. And you can read about Convex by the way in a paper. Um, yeah. They have an archive, CompNet, bro. Yeah, you can read this paper if you are cool in reading papers. Yeah, you can read it. This is a transformer model by the way. So like in computer vision, before people are using convolutional neural networks, but since transformers were like became a thing, we have now vision transformers, which not okay. It depends, project by project, which outperforms the other, but they both work pretty well, so you can use either. Nice, we are at 71% F1 score. Hopefully we get to. We still have a long way to go, bro. We still have to get to 90. We still have a long way to go. We still have a long way to go, bro. Even to get to my score, this score, right? This score only uses a gradient boosted decision tree. So even to get to this, we still have a long way to go. Like at the current score, 0.71, we will be number, bro. We will be number 126. 126 with the current score. But hopefully it improves. Hopefully it improves. I'm gonna wait for it to get to like five, five epoch, the fifth epoch. Then I call it a night now. Then we can continue from there, like maybe tomorrow or Thursday. How long do you want me to do these streams? My 4 viewers, did you enjoy the stream? Can you comment how long you want me to be doing these streams? You are the ones to tell me. If it was pretty insightful, I can even be doing it like every night from 8:30 to 10. Yeah, but it depends if there's interest or not. If there's no interest, there's no need for me to be doing it. Yeah. So can you comment in the chats, bros? Bros and girls. Oh, and there's something I've not shown you. There's something called callbacks. Yeah, like for example, right now it's not saving like the best model automatically. So if you want to save the best model automatically, you have to like add a callback called um, save model save model callback. Yeah. Now this will save the best model automatically. Like for example, 0.72 is greater than 0.71. Oh, and you have to like specify which metric to use. Um, yeah, I remember. Yeah, yeah, you can see F1. I'm not really sure, but we can see. Save. If you're not sure of something, always go back to the documentation. Uh, Checking callbacks. I hope so. Yeah, save model callback. Oh, monitor. Yeah, it's called monitor. So you have monitor and comparison. Comparison can either be NP less or greater. Since you're using F1 score, it should be greater. Like greater the better. Yeah. So usually loss of metric being monitored. Mm, so um, here it's not metric, it's monitor. And then we are monitoring the F1 score. Now I'm not really sure if we are supposed to like use right here, this right here, by possibly yeah. And then comp CM, is it CMP or comp? Um, Comp, yeah. Comp is MP dot grade. Um, yeah, MP dot greater. Nice, nice. It seems you're not like getting out of 70 soon, bro. But there's a lot you can do. Change the model. We are using convex tiny. You can change the image combinations. We can do a lot of things. Depends on your creativity, man. Use more augmentations, for example. Um, yeah. I'm only waiting for you to get to fifth epoch. If you don't see any significant improvements, no, this is the perfect explanation for the save model callback. See, if you are only training three folds and then the training ends here, the last model you'll get, I mean the weights, the model weights, because at the end you get the model weights, yeah? You'll get a 0.7061 model since you're not using the save model callback. In essence, you'll get the last model train. But if you use the save model callback, this one now, you'll get when the training ends, the best model is automatically loaded or returned. So we get the 72 F1 score model. Yeah, but the 72 F1 score model is pretty lame. Honestly, it's not so good. Yeah, because the 72 now, we are at 123. At least get to 80. Um, 80. Where will 80 place us? Um, yeah, at least get to top 100 then. I hope we get to top 100 then. But yeah, if it doesn't improve though, I'll call it a night. Then we'll try to improve it. Maybe tomorrow. Yeah, it does. It only depends on the engagement. If people are interested, I think I will be doing it every night, except weekends, bro. We can't. Weekends we have to groove, bro. We have to groove. We only live once, man. You have to have fun. But thank you guys for joining the stream. So encouraging. I feel like not many people join the stream because it's like I feel like Twitch has a like small learning curve, small or just a little learning curve compared to YouTube where you just log into the stream and watch. Maybe I'll be doing a dual stream YouTube and Twitch, but yeah, I'll be doing. But all this will be recorded and saved to my YouTube channel. So if If you're not subscribed to my YouTube channel, please do. Please subscribe to my YouTube channel, man. Please subscribe to my YouTube channel. Yeah. Honestly, if it doesn't get to more than 72, I mean, I'm just ending the stream. Um, yeah, because I don't think if it doesn't improve right now, let's fucking go. Let's fucking go, bros. Let's fucking go. We are now at 76. 76. Are we top 10 yet? I mean, are we top 100 yet? Still, we have a long way to go. At least, yeah, we are at 108 right now. We are at 108. Let's fucking go. Okay, now I'm not ending the stream. I want to see. We'll wait until the last one ends, man. We'll wait until we get a better F1 score than this. But why is it? Why is the chat so quiet? I mean, guys, can you like text, or it's my chat which is hanging? Can you like text me in the Twitch chat? Are you enjoying the stream? Let me know. What should I improve? Let me know. Yeah, honestly, I think I'll be streaming very frequently. If the engagement is great, I'll be streaming frequently. Let's fucking go. Honestly, if we get top 100, top 100, then we call it a night, right? Top 100, then we call it a night. Top 100, then we call it a night, bros. Top 100, then we call it a night. Top 100, then we call it a night. Let's fucking go! Let's fucking go, bros! Let's fucking go! Let's fucking go, bros! I mean, tushafika top 100, brother. Honestly, tushafika top 100. I think we can all sleep. We can all sleep happy. Tushafika top 100. Tuko 1770. Tuko number 94 sahi. Tuko number 94, bros. Tuko number 94. Tufike top 50. Tufike top 50. 8 top 50 ni ngori. 8 top 50 ni ngori. Top 50 ni ngori. Top 50, top 50. 85%. 85%. 85%. 85% really. Like we only have like okay, we still have more epochs. We have like how many? We have like 7 more epochs. I mean, bro, it doesn't even hurt. Let's chill. Let's chill until all the epochs are zimemaliza kutrain. Yeah? Let's chill. Let's chill. Let's chill. Let's chill. Yeah. Let's chill. Let's chill. Let's chill. I feel like we can get to top 50. I feel like we can get to top 50 tonight. I feel like we can. uh, yeah, I feel like we can. Okay, but this is a hypothetical. We have not even submitted yet. But the CV was pretty stable. Like in my previous experiments, the CV was pretty stable. Like 87, 87, 88, 88. So I feel like the CV we get here will translate well in the leaderboard. Yeah. But anyway, if we cannot get to top 50, I mean, it's still a good one. Yeah. Yeah. So I'm going to end the stream right now. At least you're top 100 in the first stream. Hopefully tomorrow or Thursday. I'll see. I'll see. I'll see. I'll see. If you enjoyed the stream, make sure you text me on WhatsApp and encourage me to do this more because it's the encouragement. It's the encouragement that counts. Yeah, it's the encouragement that counts. So to everyone who joined, thank you so much. See you in the next one.